In this video, we are going to look at shortcut methods that use perfect squares. You're going to take your notes in your booklet on pages 6 and 7. Let's start by defining what a perfect square is. It is a number that is made by squaring a whole number. In other words, a number such that when you take the square root, you get an integer. So we're going to just start by looking at our perfect squares up to 16 squared. So what I've done here is I've just squared. So 1 times 1 is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on, all the way up to 16. It is important that we recognize these, especially up to about 12, so that when we see them, we know they're perfect squares, and our brain starts thinking about, hey, this might be one of those special shortcut methods that I can use. So get these written down and then just kind of practice with them each day. Before we look at our two shortcut methods, I'm going to start by doing a little bit of multiplication. You can do this off to the side or on another piece of paper if you would like, but I am going to start by multiplying a plus b times a minus b. So I've got binomial times binomial here, so I'm going to draw my box. I'm going to do a plus b, a minus b, so that's going to be a squared, ab, negative ab, and b squared, negative b squared. Don't forget your negative there. When I combine like terms, these both have ab. ab minus ab is 0. So these end up subtracting out. So what I get is a squared minus b squared. This is a formula that I'm going to use in order to solve, or in order to factor, what we call difference of squares. So let's go back into our booklet and let's take a look at our first method. Our first method using squares is our difference of squares. If I have subtraction with two perfect squares, I can factor using the formula that we just showed by multiplication. And it's pretty simple to do. First, let's talk about when we use this. We're going to use this when you have a binomial, so two terms, where they're both perfect squares, and I have subtraction. So the subtraction is the difference part, the squares is the perfect squares part. Two quick steps. First, you're going to determine the values of a and b by taking the square root, and then you're going to use the formula to factor. This is one of my favorite because it's very easy and it happens a lot. So let's look at example 1 here. We're going to do 4 examples and you'll be surprised at how fast they go. First, I notice that this is two terms. It is subtraction, and then this is 1x squared, that's a perfect square. This is 49, that's a perfect square. See my 1 and my 49, both perfect squares. So I'm going to determine my values for a and b by taking the square root. The square root of 1x squared is just x. The square root of 49 is 7. To factor, I'm going to follow my formula. So I'm going to come back to this. Everywhere I see an a, I'm going to put x. Everywhere I see a b, I'm going to put 7. And that is all there is to it. Let's look at example 2. Again, this is subtraction. 9 and 100, those are both perfect squares. There's the 9, there's the 100. So the square root of 9 is 3. The square root of 100 is 10. So when I decide on my a and b, square root of 9y squared is 3y. Square root of 100 is 10. Going back to my formula, a plus b, a minus b. So again, I'm looking right here. I'm going to do 3y plus 10 and 3y minus 10. Let me try that again. And that's just using my formula. I could multiply to check myself. but the formula means that it works every time you have subtraction with perfect squares. Let's do the next one. Looks more complicated, but I'm going to look. I've got two terms. I've got subtraction. The 4 is a perfect square, and the 81 is a perfect square. So square root of 4 is 2. Square root of 81 is 9. So when I find my a and b here, square root of 4x squared is 2x. Square root of 81y squared is 9y. And then following my formula, I'm going to do a plus b, a minus b. All right, let's do example 4. It's going to follow the exact same thing. So 25 and 16, both perfect squares. There's my 25. Square root of that is 5. Here's my 16. Square root of that is 4. So I'm going to find my a. Square root of 25, x squared is 5x. Square root of 16 is 4. Then I'm going to go back to this formula. A plus b, a minus b. So I'm going to do 5x plus 4. 5x minus 4. It is important to note here, it has to be difference, it has to be subtraction. So if I have x squared plus 16, this method doesn't work. That's prime, it's not factorable. If I have 4x squared plus 81, that's prime, that's not factorable. It has to be difference, it has to be subtraction. Okay, we have a second method that uses our perfect squares. So in the second method, we'll still be using these perfect squares here. So again, we should be able to recognize them. And I will say the difference of squares, that's a shortcut method that I use quite often. The next one, which is our perfect square trinomials, that is one that I don't use quite as often. We are going to start by actually just doing some multiplication here. The first thing I want us to realize is that if I have a plus b squared, that means a plus b times a plus b. So if I were to multiply this, and that's just the definition of squared, by the way. Multiplying, a times a is a squared, a times b is ab, a times b is ab, b times b is b squared. This time, combining my like terms, they're both positive, so I add. So I get a squared plus 2ab plus b squared. Okay, this is going to be a formula that we use as well. In this formula, when we're factoring, we're actually going to take it from here back to there, and we'll look at how. Before we do that, let's take a look at if we have a minus b squared. So again, when you have something squared, that means multiplied by itself, so be careful there. And if I multiply here, I know I'm doing this fast. We should be pretty good at multiplying by now. And then that's plus b squared. Negative times a negative is positive. I get a squared minus 2ab, because that's a negative 1 and a negative 1, plus b squared. So again, this is going to give us a formula, and I'm going to be able to go from here back to there. Okay, let's go back to our booklet and take a look at how we're going to use this. So here's the two formulas that we just figured out using our multiplication. And if you're going to use this method, they do have to be memorized, unfortunately. What we're looking at when we have a perfect square trinomial, we should have those perfect squares, 1, 4, 9, 16, 25, etc., and so on. And the first and the last term should be those perfect squares. Then, if you find the square root, determine a, find the square root to determine b, this middle term should be twice the product of the first and last term. Sounds complicated, but when we do our example, you'll see that it's not all that bad. Let's start by writing out our steps. So first, we should use this method when you have a trinomial, 3 terms. First and last terms are perfect squares. The first thing that you're going to do is determine the values of a and b, again by taking the square root. You're going to confirm that the middle term is 2 times a times b, or negative 2 times a times b. And if it isn't, you need to go back to the box method. If it is, you use the appropriate formula to factor. So let's take a look here. First, 9 and 1, those are perfect squares. If I come back to here, there's my 9, my square root is 3. There's my 1, my square root is 1. So I'm going to come back, and I'm going to determine here that my a is 3x, taking the square root, and my b is 1, taking the square root. So this is a squared, this is b squared. Now, I want to do 2 times a times b, and I get 6x. So this is minus, see how it's 6x, 2ab. So I do have the correct setup here. I've got a squared minus 2ab plus b squared. So using my formula, because it's minus, I'm going to do the minus one. My answer is going to be a minus b squared. I don't have to do the whole box method. Now, on example 1, probably the box method wouldn't have been all that bad. You look at example 2, though. If I use the box method on example 2, I have to do 16 times 25. That is a giant number. I don't want to look at all those factors. So this is the benefit of having this shortcut method. Let's take a look at what we have here. So first of all, 16 and 25, those are both perfect squares. Right here is the 16, so the square root is 4. Right here is the 25, so the square root is 5. Okay, so taking a look, I'm going to first determine a by taking the square root. So this is my a squared. So a is 4y. This is my b squared. So b is 5. And now I'm going to do 2 times a times b to make sure my middle term works. So 2 times 4y times 5. So 2 times 4 is 8, times 5 is 40. So that does work. So notice what I have here is a squared plus 2ab plus b squared. And according to my formula, right there, that's going to give me a plus b squared. So I'm going to get a, which is 4y, plus b, which is 5, squared. Then I didn't have to look at all those factors of 16 times 25. Again, that's going to give me a pretty big number. Okay? All right, I'm going to have you do 3 and 4 on your own and then check with me to make sure that they are done correctly using this method. And again, I will say, this particular method, the perfect square trinomial, it is one that I don't typically use unless I've got fairly big numbers. I recognize them as perfect squares. However, the difference of squares, this one, the a squared minus b squared, this one I use quite often because that one's going to occur very often and it's very easy to use. I get to just go perfect squares, 2 terms, subtraction, and I can go straight into my formula. And that is it for our shortcut methods using our perfect squares.